Hey guys, I'm going to run through the review for chapter 2A. I want to do this because I want you guys to be aware of like how it works for my class. The review and the test itself will be very similar. So yeah, one thing to note is that it's going to be kind of like a hybrid sort of a test where you'll see questions or answer questions in ALEKS, but I will have a paper printout of things of where you can show your work or at least maybe do some of your calculations in any way. So this is how it's going to look on paper. So say for like question 1, it says graph the functions in ALEKS, and you can use these graphs here if it helps you. So you don't have to put your work here, but if you want, that's great. I like it when you guys show your work. But if you're able to answer just in this window, like what you see in ALEKS, that's also great too. So for question 1, and we don't even really need to graph in question 1. It says below is the graph of y equals the absolute value of x. Translate it to make the graph of y equals x plus 4 and plus 3. So if you're doing the review right now, you can click on that button in there with the 4 directional arrows, and then you can click on the vertex and you can move it around. And so let's read the transformations. Plus 4 on the inside of the absolute value would mean that I need to move it over to the left 4, and the plus 3 that happens on the outside would mean that we would move it up 3. So I think right there is where it should be. So I just translated the graph, and if you want to check your work, on the review there's a check answer button. It won't be there on the test, but so utilize it on the review. So I can check my work, and that is correct. So for this question right here, it's gonna be testing your knowledge on maybe linear or absolute value and your knowledge of transformations. How do you move it left? How do you move it right, up and down, so on and so forth. So question 2, we have graph the line of 2x minus 5. Okay, so what I would do here is probably use the pencil button on the right side, and I would move this pencil and plot some points. So I know that this is linear, and so I like to graph my linear functions by putting a point on the y-axis where it's going to cross. So in this case, -5 is the y-intercept, and it has a slope of 2. So if I count up 2 and over 1 from that spot right there, then I should have those 2 points. I think as far as drawing a line, if I press the line button, okay, so this line button right here, I'm going to put a point there, and then I'll put a point through the other line right there. Let's see if I do a check answer, I get that correct. Yes, I do. So there you go. That's how I would do that one. So that's a linear, just graphing a linear. Shouldn't be too bad. I like to graph the first point, put the point on the y-intercept, and then do the slope. So on the actual paper review, really nothing you have to do here if you don't feel like you need to. But if you want to, maybe if you're on the test and you want to graph it here to be a little bit more confident in what you're putting in ALEKS, please do so. And if you put your work on this paper, I can actually, let's say you put your work on this paper right here, and maybe you do something wrong here, but maybe you do it right here, I can at least give you, if not all the points, but partial points, if you at least have it partially correct. So keep that in mind. Okay, going to question 3. So for question 3, we have the graph of f is translated a whole number of units horizontally and vertically to obtain the graph of g. Write down the expression for g. So the function f is defined by f of x is equal to negative. Alright, so we just have to make an equation for g. So f of x is equal to negative absolute value of x. So what is g? So I'm looking at the position of the vertex, and the position of the vertex of g is 1, 2, 3 units to the right and 2 units up. So maybe you have, let's say we have this right here. I'm going to write down what f of x is. So it says that f of x is equal to negative absolute value of x. And g of x has to be very similar. So we have negative because it's still facing downward. And then we're going to have x minus 3. So the reason why I put x minus 3 on the inside of the absolute value signs is because the graph of g is moved to the right 3. So that's going to be minus 3 on the inside. And then plus 2. So plus 2 because it's 2 units up. So this was f, and this is the equation for g. And so let's try and type that in here. So in this field right here, let's see, pull up the keyboard, maybe. All right, so I'm going to have negative. I'm going to click on the absolute value signs in the box there, and then we should have x, and we were going to do minus 3. Then on the outside, can I put my cursor on the outside? I don't, there we go. We need to have plus 2. Let's go ahead and check and see if that's correct. All right, so we're good. For 4, similarly, we're just going to write an equation. So we have negative x squared for f, that's kind of the gray line, and then the graph of g is the blue line, and I need to make the necessary equations to the equation to write something for g. So I'm going to put a negative here. I'm going to use some parentheses too. So parentheses, and I'm going to put an x here, and then close parenthesis, and then I'm going to square that. So to square that, I'm going to press the exponent button that you see there and squared. So this is the same thing as f of x. I just added parentheses, and that's okay. And then I see that the graph of g is 2 units to the left. So inside here, I'm going to do a plus 2 to move it to the left 2. And then on the outside, I'm going to do minus 4 to move it down 4. Let's check that. All right, and we're good. Question 5. The function g is defined as follows. If the graph of g is translated vertically downwards by 8. Well, one second. I'm actually going to write this down. So 5x squared plus 7. So we have 5x squared plus, and I'm not going to write it there. 5x squared plus 7, that's the function that we were given. It's called g of x, and they want us to write an expression for f of x, so I guess we'll say g of x equals here. We'll call this f of x instead of g. Okay. Let's do that. Give myself a little bit more space. And we'll call this f right here. All right. And what do we want to do? So downwards by 8. We want to vertically translate it down by 8. So that means I'm going to subtract 8 from there. So I get 5x squared minus 1. That will move it down 8. What else do we need to do? If the graph of g is translated vertically down 8 units, it becomes the graph of f. So the final expression for f, well, there you go. So that would be my final expression. So 5x squared minus 1. So we'll put that in here. 5x, use the exponent, squared. And then minus 1. Let's go ahead and check it. And we're good. All right, question 6, probably very similar. If the graph of h is translated vertically up 3 units, it becomes the graph of g. I don't think I'm going to write this one down. I have 5x, and then let's square that, squared. And it's minus 2, but we're moving it up 3, so negative 2 plus 3, that's going to turn into plus 1. All right, there you go. For 7, below is the graph of x cubed. translate it to make the graph of x minus 3 cubed minus 4. We haven't really talked about cube functions, but we're not going to do anything differently. We're just going to grab this point right here. We're going to move it, so minus 3 on the inside would be to the right 3. And then we're going to move it down 4. 1, 2, 3, 4. So we don't need to change how we've been doing this all along. So let's go ahead and check that. And we're good. Let's go to question 8. Below is the graph of 3 square root of x. Again, we haven't really talked about functions that use square root of x, but we're not going to do anything different in terms of the rules. So let's move this right here. We just have to move it to the right 3. So move this function to the right 3 and up 1. And we'll check it. And we're good. All right, question 9. Graph the parabola. All right, so we're graphing this one right here. So we have x minus 2 squared plus 4. What number is that one? This is number 9. X minus 2 squared. Oh no. I closed it. So number 9, I had x minus 2 squared plus 4, right? Yep. So I kind of like to graph these on paper, and then I'll put it into ALEKS. So this is going to be a parabola where it's going to be moved to the right 2, and then up 4. 1, 2, 3, 4. So that's where I'm going to put the vertex, right there. Now in here it says that we need to plot 5 points. The vertex, 2 points to the left and 2 points to the right, and that's what we're going to do. So I have my vertex. We're going to plot 2 points to the left, and since there's no constant right here, that just means that the constant is 1. So for the 1, 3, 5 rule, we're just going to do that. So 1, and then 1, 2, and 1, 2, 3. So that should be what my function should look like. I have 5 points. I have the vertex, 2 points to the left, 2 points to the right. So that kind of gives me an idea of what I want to do. You're going to use, I like to use the pencil. So we said 2 units to the right, 4 units up for the vertex. And then using the 1, 3, 5 rule. So there's 1, 1, 2, and 3. And then I can do that same pattern over here. And then once you do that, if you click on the button directly to the right of the pencil, if you have all those 5 points graphed, then if you push that, it will put a line through that. Let's go ahead and check. And we're good. Alright, so for 10, we're doing the same thing. I have negative 2 x minus 3 squared minus 4. So negative 2 x minus 3 squared minus 4. So I'm going to move this to the right 3 and down 4. Should put it right there. Now, this is going to be a downward facing, and the 1, 3, 5 rule, so 1, 3, and 5 has to be changed by a factor of 2. So that's going to be equal to 2, 6, and 10. I should only need these ones right here. So I'm going to go over 1 and down 2, over 1 and down 2. Then I'll have to go over 1 and down 6, but I can't do that here. So let's do that in here. Okay, so we have this right here. So I said that we're going to move to the right 3 and down 4. I'm going to put a point there. I'm going to go over 1 and down 2. And then I'm going to go over 1 and down 6. So that should put me at negative 12. Put a line through it. Let's go ahead and check it. Alright, and we're good. Alright, for 11. Now for 11, I kind of have some notes here. So for 11, you will be presented with graphs or equations. And follow the directions in ALEKS. So for 11, I've been given graphs. You might have a problem where it gives you equations. And maybe I can try and find some of those in this video. Maybe I'll try and do that. So in this case right here, so for each coefficient, choose whether it is positive or negative. So for graph A, so we're talking about the graph right here. So the coefficient of capital A that you see for ax squared, is that A going to be a positive or a negative number? And so because the graph is upward facing, I know that it's going to have to be positive. Same for B, but for C and D, they are downward facing, so that would mean that their coefficients have to be, that would have to be negative. Okay, for part B, it says choose the coefficient closest to 0. So the coefficient closest to 0, so let's say that I'm going to use this space right here. The lower the more compressed the graph is, that means the coefficient is closer to 0. So that could be either downward or upward facing. So what I'm going to be looking for here is the most flat of these graphs right here. That's going to be the coefficient that's closest to 0. So I'm going to say A. So if you look at A, that is the graph that has kind of a wider, it's just more wide. And then for C, choose the coefficient with the least value. So the least value, I'm going to have to say it's between C and D because we're talking about the least. So that's going to be the most negative, okay? So now between C and D, which one's going to be more negative? And so it's going to be D. That one should be more negative because it's more of a narrow graph. So it might have like a coefficient of -4, while C might have a coefficient of like -1. You can see that it's more narrow and it's downward facing. But let's go ahead and see if I'm right in all of that right there. Yep, so we're good. So be sure that you can answer questions like that. So that's question 11. Let's see if, let's try another. Okay, perfect. So for this one right here, I have equations. So maybe you're working on your review and you have something like this. So for A, for each parabola, choose whether it opens upward or downward. So we're choosing which one opens upward or downward. So for this one right here, because it's negative, that's downward. Same with this one, that's going to be downward. This one right here is going to be upward because 2/3 is positive, and this one's going to be upward because 3/4 is positive. For B, choose the parabola with the most narrow graph. So the most narrow graph is definitely going to be the -3x squared because 3, ignoring if it's negative or positive, doesn't really matter. The 3 is a larger stretch factor. So it's a larger factor that you're going to multiply the 135 rule with, and so that one's going to be most narrow. And choose the graph with the widest graph. And so that's going to be either 2/3 or 3/4. It depends on which one is smaller. Is 2/3 smaller or 3/4 smaller? So 2/3, which is 0.66 repeating, and then 3/4, which is 0.75. So whichever one has a smaller coefficient is going to give the widest graph. So I'm going to go with that right there. Let's see if I'm right. Okay, and we're good. All right, so that's an example that you can expect to see on 11. Again, you might get one with graphs. It's going to ask questions that are similar but different. And then you might get ones with equations. All right, moving on to 12. The graph of the function with a vertex of -1, -2 is shown in the figure below. Find the range in the domain. All right. Write your answers as inequalities using x or y as appropriate, or you may instead click on the empty set or all real numbers as the answer. So this is a parabola, so that's going to be easy for me. For the domain, that's going to be all real numbers. Yep. Hopefully that's what all reals means. I don't know. For the range, so if I click in here, so the range is not all real numbers. I'm going to have to use inequalities, and the range uses y, so it's y, and I have a minimum, so that's going to be y is greater than or equal to, and the lowest y value is -2. So -2. So we're just looking at all the y values for there, and then let's go ahead and check, see if I got it, and we're good. All right, so make sure that you know range is the y values, domain is the x values. For parabolas, for quadratics, it's always going to be all real numbers. All right, for 13, use the graph of the parabola to fill in the table. Okay, so for A, does the parabola open upward or downward? That's pretty easy, downward. Find the coordinates of the vertex. So I think it's going to be 3, 1. So it's going to be 3, 1 for the vertex. That's pretty easy, just looking at the graph. Find the intercepts. All right, so this one, I'm actually not sure how they want us to write this. So for the x-intercepts, we're not going to write them we're just going to write the value of x. We're not going to write them as coordinates. So that should be 2 and 4. So I'm going to say 2, and then there's a button up here. It's the one to the left of none. If you click on that, it will give you another box to write in a space. So 2, 4. So those should be where the x-intercepts happen. For the y-intercepts, that's going to be at -8. I think that's how they want us to write it, but I guess we'll find out when we check our answer. For D, find the equation of the axis of symmetry. So the axis of symmetry is the line, the vertical line that crosses through the middle point. So that's going to be at x equals 3. At x equals 3, that's where it's going to be symmetrical. I think that's how we're going to type it in. We're going to type it in as x, here we go, equals 3, and that should be the equation. So make sure that the equation is x equals the x value. Let's go ahead and check and see if I'm formatting this. So I think that's exactly how you want to format your answers there. All right, for 14, consider the following quadratic function. Write the equation in the form, vertex form, then give the vertex of its graph. All right, so I have -3x squared plus 30x minus 74. I'm going to write that down in here. Yeah. So what was it? It was -3x squared plus 30x. Man, these are large numbers. That's not cool. Minus 74. Okay, so we're going to write this in vertex form. If you guys remember, we talked about in class, this is in standard form. So to write it in vertex form, we need to find the axis of symmetry. So the equation for that is x is equal to -b over 2a. So in our case, that's going to be b is 30. So this is b, this is a, and this is c. So -30 over 2 times by -3. So that's going to be equal to -30 divided by -6. So that's going to come out to be, that should be 5. It's a positive 5. Okay. So for the vertex, I know the vertex is going to be 5, comma. Now in order to find the y value, I have to plug this in for x squared, or for the x. So -3 times by 5 squared plus 30 times by 5 minus 74. I'm probably going to pull out a calculator because I don't want to do times multiplication with those big of numbers because I'm not good at multiplication. So if you can type this into your calculator, great. So -3 times by 25 plus 30 times by 5 minus 74. Okay, that's not bad. That's going to be -75. That's going to be plus 150. And then minus 74. Does that come out to be like 1? Let me double check. So I got -3, 5 squared plus 30 times by 5 minus 74. Yep, that comes out to be 1. So that's the y value. All right, so I found my vertex first, but that's okay because that's going to help me find the equation here. So for f of x, for the vertex form, the a value is just going to be the same. So I know it's going to be -3, and then x minus, or plus, we'll wait and see. So what is this going to be? Well, because the vertex is at positive 5, yeah, that's going to be -5 squared, and then plus 1 for that right there. So this right here should be a vertex form. So -3, -3, and then I'm going to do parenthesis. We're going to give it x. We said -5, close parenthesis. We're going to square that. And then it was +1, I think we said. So +1. For the vertex, that's 5, +1. Okay. For b, graph the function. To do this, we're going to plot 5 points. So I'm going to put a point at I don't know why, but I can't. It's like frozen for me. I can't. What if I do check? I think Alex froze on me. See if I can go back into it. There we go. All right, so 5, 1. So that's going to be my vertex. And it has a stretch of 3. It's also downward facing. So I'm going to go over 1 and down 3. 1, 2, 3. And then for the 1, 3, 5 rule, so I'm next going to go over 1, and then I'm going to go down 9. So that should put me at -11, I think. Let's see if this all checks out. Let's go ahead and check my work. All right, we're good. All right, perfect. All right, go on to 15 right here. Answer the questions below about the quadratic function. So does the function have a minimum or a maximum? This one's going to have a maximum because it starts with -2x squared, which means it's going to be downward facing, which would give it a maximum. What is the function's minimum or maximum value, and where does so we need to find the vertex. That's basically what B and C are saying. We need to find the vertex. So we got -2 x squared, and then -20x, and then -46. All right, so this is in standard form, so to find the vertex, I need to use the formula. So x is equal to -b over 2 times by a. So that's going to be equal to 20 over -4, which should be -5. So my vertex is going to be -5, comma. Now I need to plug -5 in for x. Like that. Let's see, so it's going to be -2 times by +25 plus 100. I think that is -46. So that's going to be -50. So it should come out to be 4, I think. Let me double check here. So we have -2. I'll just have a calculator right here. -5 squared minus 20 times by -5 minus 46. Yep, that comes out to be equal to 4. So what is the min or max? So this is going to be a maximum. It's going to be 4. Where does the maximum or minimum occur? That's going to be at -5. So what is the function's minimum or maximum value? 4. And then this part right here will be -5. Make sure that's right. And we're good. All right, so that's going to be the last part that you have to do in ALEKS. Now, as for these last two, I think there's only going to be one of these on the test, but this is just graphing in, intercept form. So I can see here my intercepts. So if I take x minus 5 and set it equal to 0, x minus 1, set it equal to 0, solve for x by adding 5 and adding 1, I'll get x equals 5 and x equals 1 as my intercepts. So 1 and 5 right there. Okay, now the axis of symmetry is going to be exactly halfway in between these lines right here. So what, 1, 2, 3, 1, 2, 3. So the axis of symmetry is going to be at 2. You don't have to graph the axis of symmetry, but if it helps, go for it. And then from here, since I know that this is the axis of symmetry, it happens at 2. If I plug 2 in for x and solve it, I'll get the vertex. So I have 3, 2 minus 5, and then 2 minus 1. So I get 3 times by negative 3 times by positive 1. So that's going to become negative 9. Is that right? If I plug in 2, negative 3, 2 minus 1. I think that's right. But for some reason, that's not... I don't feel like that's checking out right now. 1, 2, 3, 1, 2, 3. Okay. We plugged in 2, 2 minus 5. Yeah, that's negative 3. Plug in 2 right here, 2 minus 1. Okay. Vertex is going to be at negative 9. So this is negative 8. This would be negative 10. So this would be negative 9. The 1, 3, 5 rule would be over 1 and up 3. So over 1 and up 3. So negative 9, negative 8, negative 7, negative 6. Let's see. 1, 3, and 5 times these by 3. That's going to result in 3, 9, 15. Well, found my problem. I wonder if you guys are watching and was wondering what I was doing wrong, because I just found out what I was doing wrong. So what I was doing wrong is I have that in the wrong spot. This should be 1. We said x minus 1 is equal to 0. We said x was equal to 1, not negative 1. Okay, that was not looking right before. Okay, so that's going to change this part right here, where the axis of symmetry is actually going to be at 3. Not at 1. So then we're going to have 3. We're going to plug in 3, so we get 3 minus 5, and then 3 minus 1 here. So then we're going to get 3 times by negative 2 times by 2. So that's going to become negative 6 times by 2, and that's going to become negative 12. Okay, I think that should be right. So negative 12. And then the 1, 3, 5 rule. So that's still going to be 3, 1, 3, 1, 3, 9, and 15. So if I go over 1 and up 3, that should put me here at negative 9. And then I'd go over 1 and up 9. There we go. That should be right. Okay, perfect. So that's how I would draw this one right here. Okay? Let's go to this one right here. So we have x minus 6, set that equal to 0. That means x will be equal to 6. That's going to be 1 of the x-intercepts. Then x plus 2, set equal to 0. Subtract 2, so x will be equal to negative 2. So right there. And this means that we're going to have a, let's see, 1, 2, 3, 4, 1, 2, 3, 4. So is that going to be at 2, I think? Hopefully I got this one right. 1, 2, 3, 4, 1, 2, 3, 4, okay. And then we're going to plug in 2 into the equation. So we got 1/2, 2 minus 6, 2 plus 2. So we have negative 1/2. We're going to have negative 4. And then we're going to have 4. Negative 1/2 times by negative 4. That's going to result in 2 times by 4. So that's going to be equal to 8. So we're going to have it up here. Let's see. Let's use the 1, 3, 5 rule. And times by 1/2, times by 1/2, times by 1/2. So that's going to be equal to 1/2 That's going to be equal to 3 halves. This is going to be equal to 5 halves. I don't think we actually really need to do that right there. So over 1, 6, 7. I'm just going to draw it like this right here. I already know this is the vertex, and I already know where it's going to go to. So I'll just do the best U shape I have, or that I can draw, that goes through those right there. So, and I'm going to call it good right there. That will be okay with me. All right, and that should be everything that you should see on the test. Should be exactly the same thing as you see in this review. So, all right, hopefully you guys found this helpful, and good luck.